In this sort of bonus video on improper integrals, I wanted to draw your attention to the function 1 over x to the p, because if you're in an AP calculus course, what you'll want to be able to do is recognize quickly whether or not those type of functions converge or diverge when they're involved in improper integrals. So let's just notice that y equals 1 over x to the 1, which we see here. We've already seen that diverges when you integrate it from 1 to infinity and when you integrate it from 0 to 1. Now, take a look at the graph and ignore the left half. We're just going to focus our attention on the right half of this graph. Watch what happens to its behavior as p gets bigger than 1. So what you see is that it's getting closer and closer to the x-axis, but it's getting fatter and fatter in terms of its the region near the y-axis, right? So that we should expect, therefore, that when p is bigger than 1, the limit as x goes to 1 from 1 to infinity, or the integral as x goes from 1 to infinity under those functions, is going to converge because it's decreasing fast enough to kind of squeeze area into towards one finite number. Whereas if you integrate it from 0 to 1, it's too fat, it's going to diverge. Let's go back to p equals 1. Oops. Alright, so there's the p equals 1 is the balancing point. It fails in both directions, just a little too fat in both directions. Now, if p is in between 0 and 1, you'll notice the reverse behavior happens, right? The region between the x-axis and the curve gets fatter, and the region between the y-axis and the curve gets thinner. So those integrals, when you integrate from 0 to 1, are going to converge, but from 1 to infinity are going to diverge. All right, and so again, for like an AP exam, you'll want to recognize that very quickly. You won't want to actually do it out. You'll want to just know that, and having a good visual conception of what the graph looks like, I think, would help. So just to summarize on the next page, so if we take a look at the integral from 1 to infinity of 1 over x to the p, let's just study what's going to happen depending on what p is. We know if p is 1, then it's 1 over x, and that diverges in both cases. So let's assume that p is not equal to 1. So in that case, this antiderivative here, since it's we can view that as x to the negative p. I'm not going to think of natural log. I'm going to use the power rule. So this will become, the antiderivative will become x to the 1 minus p divided by 1 minus p. So I'm just doing the power rule there. I added 1 to the exponent and then divided. And we're going to integrate that. So again, technically I need to write this as the integral from 1 to a. The integral from 1 to a. And I'm taking the limit as a goes to infinity. And so this becomes, we'll integrate this from 1 to a, and we'll take the limit as a goes to infinity, so this equals a to the 1 minus p divided by 1 minus p minus 1 to the 1 minus p divided by 1 minus p. And of course 1 to the 1 minus p is just 1, so I really have a to the 1 minus p over 1 minus p minus 1 over 1 minus p. And now what we need to do is we want to focus our attention on this, because depending on what p is, that's going to behave a certain way. So let's first, we know p can't be 1. We've already concluded it's not 1. Let's say p is greater than 1. If p is greater than 1, that means that 1 minus p would be less than 1. Less than 0. Right? So make sure you take a second to digest that. Therefore, the limit as a goes to infinity of a to the 1 minus p over 1 minus p minus 1 over 1 minus p. Well, what's going to happen is, since 1 minus p is less than 0, then this a to the 1 minus p is a to a negative number, which means it really should be moved down to the denominator and raised to the positive version of that number. And as a goes to infinity, that means that this, with a down in the bottom, this is going to go to 0. So this is going to equal negative 1 over 1 minus p, which is more commonly written as 1 over p minus 1. However, if p is less than 1, then 1 minus p is greater than 0. And if 1 minus p is greater than 0, then this limit is going to go to infinity, and that's because if 1 minus p is greater than 0, you're raising a to a positive number, and as a goes to infinity, infinity to a positive number is going to go to infinity. So that means it would diverge. All right. So to summarize, in this box over here, the integral from 1 to infinity of 1 over x to the p will either converge to 1 over p minus 1, or it will diverge, and it will converge to p minus 1 only if p is greater than 1. And it will diverge if p is less than or equal to 1. So there, I mean, that's I think the important thing is especially for you test takers out there, just to be able to recognize immediately what, depending on what p is, and thinking of the graph, whether this diverges or converges immediately. I want that should be done in an instant. I'll leave it to you to consider this case. So I'll leave it to you as an exercise to see if you can generalize what happens there when p is not equal to 1. All right, so there's kind of a bonus video on this very common improper integral involving 1 over x to the p.